And welcome back. This time, Chapter 11, Wireless Networks. This is one of my favorite topics. As a security tester going into a company, you may be asked this question. Hey, thanks for coming in to review our system security. We have two wireless networks in our building. The wireless networks don't overlap. Both use WPA or Wi-Fi protected access. What else can we do to ensure that no unauthorized wireless access points are established? What should you do? Well, this starts your quest and your response, right? You should periodically complete a site survey to ensure that no unauthorized wireless access points are established. Site surveys generally produce information on the types of systems in use, the protocols in use, and other critical information. You need to ensure that hackers cannot use site surveys to obtain this information. To protect against unauthorized site surveys, you should change the default SSID or service set identifier and disable the SSID broadcast. Immediately upon discovering a wireless access point using a site survey, you should physically locate the device and disconnect it. Site surveys are also used to analyze antenna placement. Now, to ensure that no unauthorized wireless access points are established, you should change the wireless networks to WPA2 instead of WPA as the company had mentioned. This would increase the security for the two networks and prevent hackers from accessing the networks. However, it would not prevent an attacker from setting up a new wireless access point. So we talked about disabling SSID broadcasts for the wireless networks. The reason you would disable SSID broadcasts is to protect a wireless network from the hackers and to prevent unauthorized site surveys, right? Disabling the broadcast on the existing network can't really prevent the establishment of new wireless access points. So, there are pros and cons. Also, as security professionals, we know that disabling the SSID broadcast does not really provide huge security measures. And that's why a lot of companies just leave them up and posted. So when adding a new access point, you should ensure that you correctly configure this access point, right? Especially if other wireless access points are already in use in the area. And a new access point, you would want to make sure that it doesn't interfere frequency or channel-wise with the other access points. These are some of the things as a security tester that you would be looking for. That was kind of a lot, but I thought it was important to go through kind of a fun list of things. Now, these are the objectives for Chapter 11. And so basically we go with understanding wireless technology, right? I'll review for a lot of you. First, understand that wireless system is operating on a radio frequency or an RF spectrum between, say, 3 hertz and 300 gigahertz. Cell phones, smartphones, AM/FM radios, radar systems, in addition to networking devices, are operating, though, in this range. So just be aware of that. Most wireless operates between 2.4 gigahertz and 66 gigahertz, and wireless technology, especially in the Internet of Things, is continuing to grow and utilizing much of this spectrum. So for a wireless network to function, you must have the right hardware and software, as well as the technology that sends and receives RF signals or radio wave signals, right? Other things that use them are listed here on this slide, including baby monitors. So they're everywhere and growing. Now, components of a wireless network. Any network needs certain components to work. Yes, we know that. So on a typical LAN, these components are going to include a NIC card, the network interface card, the TCP/IP, right, the transport mode, and an Ethernet cable. Now, wireless network, or WNIC, card, right, WNIC, is going to transmit and receive wireless signals and access points, which are the bridge between this wired world, which is a network we've largely been talking, and this wireless world, right, of networking protocols, right, across this RF spectrum, which replaces the wire components along the way. Now, continuing with some more components, right, we have these access points, or APs, right? An AP connects to the network via an Ethernet cable, or sometimes it's bridged, right? So there's a bridge, which is like between the LAN and the WLAN, right? So with a wired network, a wired network that doesn't connect to a wired network is known as a bridge, right? And this could be like a peer-to-peer network. So an access point is where that RF channel is configured, right? APs are what hackers are looking for when they drive around with an antenna on top of a computer, scanning for access, right? They're looking for access points on the wireless to get to your wired network. So an AP enables users to connect to the LAN, the physical LAN, with this wired technology. And it's within some defined area or square footage. Now, the service set identifiers, or SSIDs, a service set identifier is the wireless LAN, right? The SSID is configured on an access point. It's usually 1 to 32 characters or so. It's case sensitive, alphanumeric name, right? For wireless enabled computers, it has to be configured with the same SSID as the access point. So the AP actually beacons out, or it's broadcasting the SSID, so that any user in the area who has a WNIC, that wireless NIC card, can see it. Now, many vendors have SSID set to a default setting, right? And if an AP is configured, is not, a lot of times it's configured not to provide the SSID until after authentication. So that wireless hackers, what they're trying to do is attempt to guess the SSID to make sure your client, isn't using some default ID, right? If you have a preference, it's not huge, but it's one of those layered security approaches. On your computer, this is what the SSID shows up as, right? It's important to recognize that a default SSID, this is the stomping point, can open the door to discovering vulnerabilities, right? As we learned back in chapter 6, recognizing which OS that a customer is using is essential before you can detect vulnerabilities in a system or a network, right? This is also true when you were attempting to discover vulnerabilities in, for example, an access point. So when conducting your security tests on a wireless LAN, you start by looking for the SSID advertised to determine the type of access point the company is using, right? I recommend going to the website that I have posted here. It's a NIST website, and it's you want to click the vulnerability search engine. You might type in, for example, D-Link, one word, D-Link, and then wireless. So 2 words, D-Link wireless, in the search box, and click search, right? And it gives you an opportunity to review some recent vulnerabilities with the common vulnerability scoring system known as CVSS. And look at the ones with a security level of 10 or higher. You can even click the CVE link and read the vulnerability summary information, okay? So a little more on service set identifiers then. Vendors, again, have many SSIDs set to the default value, and companies never change them, right? So an AP has to be configured, or can be configured not to provide SSID until after authentication. In fact, somebody logging on might have to load the SSID themselves as part of the process. Wireless hackers can attempt to guess that, right, as I mentioned, but we want to verify with our client that they're not using the default SSID and which ones they would like to use. Here is some of those service set identifiers. The vendor listed on the left has common default SSIDs. If we don't change the default, it gives the hacker an opportunity. This is the first place I'm going to go to guess on the list on the right? Those are going to be my default. And now I'm one step closer to getting to your wired network. Now, configuring an AP will vary depending on the embedded OS, for example. And most devices allow access through a web browser. Now, reconfiguring a wireless router is possible, right? We enter the IP address in the web browser. We provide the username and log on password. Then after we've logged on, we can check the status item. By clicking on the status tab at the top, we can click the wireless to view wireless physical interface and to configure security. So these are some of those slides that walk you through that process. Like I said, with most APs, users can access the software through a web browser because the AP has an embedded OS supporting the web server. So an AP administrator can determine the SSID and channel and configure the security. As I mentioned, the steps that you could go through, and it's also in the book as well that you could follow, right? So again, click the wireless tab and you can play with the SSID requirements yourselves. Again, well articulated in the book. And this is all part of configuring the access point. Again, to configure security, you click the wireless security tab and make sure that you have a password, right? This is the shared key, the password, often known as the shared key, pre-shared key, the shared key. The WNIC manufacturers usually supply connection management software. So you're going to get software that goes along and helps you make the connections on a console-like fashion. The determined intruder can use, remember, passive wireless sniffers such as Kismet. So if your user didn't assign a wireless LAN key, or if they didn't change the default administrator password to the access point, think of how easily an attacker could access the wireless LAN. So as a security tester, you must verify that these vulnerabilities do not exist. Okay. The wireless NICs, they convert the radio waves it receives into digital signals. Remember, digital is how the computer speaks. So the wireless NIC is converting that for us, right? Be careful when you're deciding which ones to purchase. Some tools require certain specific brands. Also understanding the wireless network, there are a set of standards, right? And it's defined by IEEE, right? They define our wireless standards for us. And so they have many projects, right? And IEEE Project 802 was developed to create LAN and WAN standards. So the working group that was assigned to Project 802 names, the working group names are also assigned numbers such as 11 for the wireless LAN. And then they add letters to denote approved projects such as 802.11. So 802 is the LAN project, and 811 is the wireless piece, and A is an approved project. And they're well beyond A by now. Okay, let's come back and talk more about this in a minute.